webinar from Epic Engineer Technologies. My name is John Stabers. I'm the Vice President of Sales here at Epic, and we're glad that you're able to join us for today's webinar, which is on selecting the proper cable assembly for your application. Before I introduce today's speaker, Brian Morissette, I have a couple housekeeping items for you. First of all, today's webinar, as all of our webinars, is being recorded, and it will be posted on our website within 24 hours, so you'll have it for future reference. Also, all participants are in listen-only mode, but if you wish to ask a question, you can do so by typing your question in the control box on the bottom of your screen. At the conclusion of the presentation, we will address the questions, and those that do not get addressed during the conclusion of the webinar, we will make sure that we answer all of those by email within the next day or two. Today's speaker is Brian Morissette. Brian has over 25 years of experience working with customers in designing and delivering cost-effective, reliable cable assemblies over a very broad spectrum of applications. And prior to joining Epic, Brian was with TE Connectivity and Madison Cable in Worcester, Massachusetts, completely focused on product design and product development roles within the organization. So without further ado, I will turn it over to Brian.
Thank you, John. First, I'd like to thank everyone for attending the webinar today. During the webinar, we'll be looking at some high-level issues that should and need to be considered to allow the proper selection of an assembly for a specific application. The first high-level issue I'll address is the installation environment. This issue really deals with whether the assembly will be installed in a static or a dynamic environment with regards to any type of movement or flexibility. And there really are two types of movement that we need to be concerned with: flexibility with regards to installation and flexibility with regards to movement during an assembly's life. And there really is a difference in the construction between the two. The flexibility associated with installation really entails the ability of an assembly to be routed easily during the installation. Now, this could mean that the assembly needs to be flexed repeatedly during the initial placement in its intended work environment, and it could mean that it needs to go around some fairly tight bend radiuses that we need to be concerned about when we actually develop the assembly. The flexibility associated with movement deals with an assembly that will be subjected to some form of flexing or movement during its estimated working life. Now, this movement could mean that the assembly is going to be installed in something such as a robotic application, and the assembly will need to be flexed and moved as the working sections or the arms of the robot move back and forth. Or the assembly may be attached to a cutting head that needs continuous back and forth movement. And both of those need to be addressed when we design a cable to be able to withstand that type of movement. Some of the issues that we can change from a cable: we can change the conductor, and we do that by increasing the strand count. Now, some of the issues with increasing the strand count, it will improve flexibility, but in most cases, it will result in a higher cost conductor. Another component that can be changed is the insulation around the primary conductor. This change could be to use a more flexible compound, but doing this usually means going to a softer compound that could have a negative impact on the flammability rating of the insulated conductor. The softer compound also can pose problems when routing or installing the assembly. The softer compound is more easily compromised and more prone to tearing or gouging when we go over any type of support structures or bending it around the corner. To make an assembly more flexible, there can be a substitution of the tapes used on the assembly as well. If the cable, for instance, is currently using a polyester tape, it can be replaced with a paper or a woven tape. Now, that will increase the flexibility with very few negative consequences. But if more flexibility is needed than what the paper tape can provide, we'd have to go to a different type of a tape, such as a PTFE. Now, the PTFE tape has much less drag resistance and therefore will provide much more flexibility. But a major drawback of the PTFE will be the cost associated with the material. It is a Teflon material, so it will be expensive. Another component of the cable that has an impact on flexibility is the outer sheath or outer jacket. As I mentioned before, with the primary conductor, we can change the material to a softer, more flexible compound to gain some flexibility. But as we saw with the primary insulation, the flammability rating of the overall cable could be impacted, and the softer compounds are more susceptible to scuffing or attracting dirt. Another way we could change some flexibility is by changing the method of application of the outer jacket. And that can have a major impact on the flexibility as well. The basic cable design would determine, though, if we use a tube-on jacket or a pressure jacket, and each one would have a better impact on one design cable or another. Another consideration of the environment is what the assembly will expose to once it is installed and what type of signal the assembly will transmit. For instance, in an industrial installation, the assembly could be expected to withstand exposure to oils, water, or any other fluids such as cleaning fluids. The assembly could also be installed and will be run over occasionally with a fork truck or walked on repeatedly by workers, something we need to keep in consideration when we develop the assembly. In a medical installation, the assembly could be used in an application where it needs to be autoclavable or sterilized repeatedly. In a medical assembly, could be intended for some of it to be intrusive to the body if we use it in something such as a scope or some type of observation tool. The assembly could also be in contact with the patient, and we'd have to make sure we manufacture it with materials that do not include PVC or other components that patients could be allergic to. If the cable is going to be used for patient monitoring, there could be a requirement to be resistant to triboelectric noise, or the noise that's caused when the assembly is moved in response to a patient moving or rolling over, causing false signals to get down to the nurse's station. In a datacom or telecom application, we may need to be concerned about UV resistance if it's going to be exposed to the elements. So something, again, we need to be careful of. The type of signal the cable will carry has an impact on the design as well. If the assembly is going to be used to carry power, we need to consider on what type of ampacity will the assembly need to be withstand. How much current should we allow for the cable or the assembly to carry? And we can change things by looking at the materials. If the assembly needs to carry a high frequency signal, then a set of materials that is able to handle those higher performance requirements could be used. But regardless of the environment, there are conductors, there are compounds, there are tapes available to meet the most rigorous applications. One of the major considerations that we need to take into account when deciding on an assembly is what type of safety and performance certifications will be needed based on the application or the installation that the assembly will go into. Highest on the agenda would be the NEC, or the National Electric Code. They are a body that recommends that assemblies be built and installed in accordance with certain guidelines based on where they're going to be installed. The NEC only recommends what the guidelines should be, but those recommendations become law when they're officially adopted by any of the local governing authorities, the building inspector, the local building people, or state governments. From there, we'd have to deal with Underwriters Labs, or UL, which is really the main certification authority here in the U.S. UL tests the components of an assembly both physically and from a flammability standpoint. If the component meets requirements set by UL, the component manufacturer can attach the UL mark to their product, which certifies it has passed all the requirements. And equal to UL is CSA, or the Canadian Standards Association. That organization conducts the same types of tests that UL does here in the States, but for all the Canadian provinces. ETL, or now known as Internet Testing Services, is one of the key performance testing authorities. ETL will test components to set criteria established by various organizations, such as category cables. So they'll take the assembly, test it to the requirements set forth by TIA to category requirements, and if you do pass, you are allowed to label your assembly or your cable with the ETL mark. One of the most heard questions that we get is whether an assembly should have a strain relief. Answer to that question depends really on what type of bend the cable will have when it leaves the back of the connector. The main purpose of the strain relief is to provide a gradual transition point from the connector to the cable or the connection point. Strain relief is used to prevent lateral movement of load that's applied to the cable from being transferred to the terminations, causing termination failure. What that really means is when the cable's moved or flexed, most likely point to fail is a termination point. And a well-designed strain relief will work to isolate the termination points away from any movement of the cable. Strain reliefs available as both a pre-manufactured and as an overmolded design, with each one having a different advantage. A pre-manufactured strain relief is typically slipped on the cable before the connector terminations are made. Once terminations are completed, everything is done with the connector. The strain relief is glued or screwed onto the back of the connector. Pre-manufactured strain reliefs are cost-effective and are pretty much available for most of the off-the-shelf type of connectors. An overmolded strain relief is directly applied to the cable and becomes an integral part of it. Because it is a part of the cable, an overmolded strain relief offers superior flex life and increases the tensile strength of the cable and the connector mating point. The strain relief may also include a grommet that's designed to be captured and held in place by an opening in an enclosure where the assembly is going to be installed. The grommet will also increase the strain relief's effectiveness and increase the entire assembly's tensile strength. So it's a great tool for increasing the likelihood the assembly is going to perform the way it should for quite a long time. Because the overmolded strain relief is bonded to the cable jacket and the connector, the assembly really does become moisture resistant at that point, and the assembly tensile strength is increased greatly. An overmolded strain relief can also be color matched to the color of the cable jacket if assembly cosmetics are definitely a concern. An overmolded strain relief can be designed as either a smooth construction or as a segmented or ribbed construction. Smooth designs are less flexible than a rib design, but are much easier to clean, which really is a major advantage in environments such as the medical field, where dirt or germs are definitely a major concern. The segmented or rib design uses spaces and walls in the back of the strain relief to construct the majority of it, and this design provides the greatest amount of bend relief. The design works by closing the segments closest to termination first, and as the cable is bent further, the segments farther away from the termination close last. Strain reliefs are really designed to be either unidirectional or multidirectional, meaning they can bend one direction or bend in all directions, though the design of the cable really does dictate, for the most part, which direction the strain relief will work. When you use a strain relief on a cable design, such as a ribbon cable or a bonded ribbon cable or a lamp and power cord, the strain relief will only bend in one direction, only flex in one direction, based around the construction of the cable. The length of the strain relief does affect how much of the load of any movement in the cable is transitioned to the termination point. The longer the strain relief, the more effective the strain relief will be in protecting the termination points. And again, we understand we may not always have a lot of room to make a longer strain relief, but again, the longer strain relief, the more protection you'll get. Depending on the type of signal that an assembly is going to carry, the frequency of the signal, and the number and type of components in assembly, we may have to shield the cable to protect it from any EMI or RFI interference. The easiest shielding that we could employ is a foil shield. It's lowest cost and really just consists of a metallic film bonded to a polyester tape. The foil tape is applied around the components that are to be shielded or isolated. And the foil tape exhibits some pretty good flexibility and is the easiest of the shields to terminate, but it definitely is not recommended for applications with an expected high flux life. Foil shield does offer effective results at high frequencies, but isn't as effective if the signal is going to be transmitted at a low frequency. Another good shield design is a braid shield. This design consists of metallic strands interwoven or braided around the core of a cable. And because of the braiding process is higher cost than the foil tape. Because of the braiding function and the number of strands involved, the braided shield is more difficult to terminate, but it's much better at being able to withstand repeated flexing. And a braid shield performs best at low frequencies. A variant of the braid shield is a spiral shield. That's a design similar to the braid, except the metallic strands are wrapped around the core of the cable without any interweaving or any braiding. Spiral shield offers very good flexibility with a fairly long flux life, but as we saw with the braid shield, is difficult to terminate and is poor protection at higher frequencies. A good shielding solution is the use of a combination foil tape and a braid shield. A combination of the foil and the braid offers a solution for all frequencies and is fairly easy to terminate, though again it is a highest cost solution. To help with the termination issues, drain wires are usually used in conjunction with any of the shields. The drain wire stays in contact with the shield and allows an easy point to terminate the shield to when you get to the back of a connector. An assembly usually needs to meet certain or set electrical performances. As mentioned earlier, an assembly is expected to carry power. There would need to be concerns about the amount of power the assembly can handle and what the current rating or ampacity of the cable assembly should be. To meet the ampacity, conductor size and the assembly length would need to be reviewed, as well as really the number of conductors in the assembly and the expected temperature in the environment that the assembly is going to be installed. With all that type of information available, a designer or we can calculate the expected loss of the assembly and suggest the proper size conductors to handle any type of current load that the customer is going to want. Signal loss or attenuation also needs to be considered when we design an assembly if higher frequency signals are going to be transmitted over that assembly. To reduce signal loss, we can look at the size of the conductor in the assembly, what material is used for the base conductor and its plating, and what material is used as an insulator for the conductor. If we change any of those components, we're going to have an impact on how good the electrical performance of that assembly will be. In some assemblies, we've got issues with crosstalk, which can impact the performance of a signal. And crosstalk is just when the signal from one component affects the signal from an adjacent component, causing the signal to cross over one to the other and be heard on both lines. We can control that issue by the use of a shield around a component or by changing the twist lathes of adjacent pairs and not allowing the pairs to nest at all inside the cable. Higher frequency signals usually require the use of components with better conductivity ratings. At a higher frequency, the use of silver-plated conductors is usually warranted, and the silver plating has a much better conductivity than copper. And the signal, though, with silver plated, usually travels down the silver coating using what's known as a skin effect, where the signal just goes around the outer layer and does not go down the center conductor at all. The higher frequencies also require the use of compounds that are foamed to allow the signal to flow unimpeded through the conductor. An assembly has several parts that are all important. We talked about the cable portion of an assembly and what goes on the ends of the cable really are equally important. The connectors at the end are actually the point of contact between the wire and everything else. And if that connection isn't very good, there's going to be a major impact on the signal going through the assembly. There are quite a few methods to attach connectors to the cable, but the method used is determined somewhat by the signal type that's going to be transmitted. Crimp connectors are attached by inserting the stripped end of a wire into a portion of the terminal, which is then mechanically deformed or compressed tightly around the wire, hence the crimp style. The crimp connector is easier and is usually cheaper and faster to produce reliable connections in large-scale operations. There are fewer, if any, dangerous, toxic, or harmful processes involved in achieving any of the crimp connections. Another type of connector is a push-press type of connector. This type of connection requires no tools and really occurs when a conductor that's been stripped of the insulation to a set length is slid inside of a connector that has contacts that grip the wire and lock it in place. This type of connection is quick to complete, but over time the wire may work its way out of the contact, especially if there's any motion on the cable down the road or in the life of the assembly. Solder connections, when performed properly, probably one of the better, most reliable connections available today. Soldering can be used on cables with both stranded solid conductors. Solder connectors usually have a solder cup or a solder eyelet, a solder hook, or a solder tail that's used to attach the wire's connector. Disadvantage to a solder connection is that it's most time-consuming connection method and requires the person doing the soldering to be quite proficient at the process. A poor solder joint can fail due to mechanical or temperature stresses in the life of the assembly, so something we've got to be concerned about. Another type of connection is an IDC connection, or an insulation displacement connection. This type of connection process forces a sharpened blade to pierce the insulation and to make contact with a conductor. This type of method, the IDC connection, bypasses the need to strip the wire of insulation before connecting the contacts to the conductor. IDC process used in the termination mainly of ribbon cables, but also can be used in the termination of hookup wires as well. From an assembly standpoint, there are several concerns when a connector is being designed or chosen for an assembly. If there's going to be any type of vibration or movement of the assembly, a locking connector may be the connector of choice. This type of connector will lock into position, and if there's any type of vibration or movement of the assembly, the locking device does not allow the connector to back out and lose any type of connection. If there's a chance that there could be some exposure to fluids, the use of a sealed connector might be another option to explore. Sealed connectors are designed to make a moisture-resistant seal between the cable and the connection point, therefore not letting any type of moisture or any type of fluid to get into the critical termination points. For some installations, the performance of the assembly is going to be determined by industry standards. These standards will really dictate that certain connectors be used to meet specific footprints for mating, as well as signal integrity. Standards such as HDMI, SFP+, QSFP, USB, and a host of others really do determine what design and what performance the connector has to perform to. So in summary, there really are many options to evaluate to ensure the assembly meets your needs or a customer's needs. These options include the cable, the connector, strain release, and a whole litany of other topics that we could talk about. The type of signal that the assembly will transmit, as well as the environment that the assembly is going to be exposed to, will determine certain characteristics of the final product. The components that will need to be reviewed are the cable design, the termination method, and the type of connector that we're going to choose to use on the assembly. When we design and choose an assembly, EPIC can work with you, the customer, to ensure that the best design is chosen to exceed the criteria dictated for your performance.
Thank you, Brian. And while Brian reviews the questions that were submitted during the webinar, I just wanted to take a couple moments to point out that EPIC has been supplying for over 60 years various build-to-print electronic products, which, as you can see here, includes a number of items: battery packs, flex and rigid flex boards, very high reliability user interfaces, electronically commutated energy efficient fans and motors, and also rigid printed circuit boards, including some rigid printed circuit boards with extremely heavy coppers. And is the case with cable assemblies. All of these products have had seminars done on them, and all of those webinars are available on our website. So with that said, I'll turn it back over to Brian to answer the questions that you've submitted and to wrap us up.
Okay. Some of the questions that we were submitted, first question, can conductors that carry power and conductors that carry signals be included under the same outer sheath? And as we mentioned in the presentation, in the webinar, we can include both power and signal conductors under the same outer jacket. But depending on the amount of power and depending on the type of signal, we may have to go to an extreme of isolating the signal or the power by doing a foil shield or doing some type of a braid shield. But definitely both power and signal conductors can be included in the same outer sheath. Let me see. Another question has come in. You've explained that cables are shielded to eliminate noise. Are connectors shielded as well? And the answer to that question is yes, within reason. There are shielded connectors that are available. And when we do a connector process, if we know that the signal is going to be a high-speed signal, we will also wrap the back of the connector with a copper foil and solder the edges to make a complete EMI RFI protected circuit from one connector down the cable to the other end as well. Another question, can all connector designs have a strain relief attached to them? For the most part, yes. We just have to make sure that when we do a strain relief, that there's enough of a part of the connector exposed that we can do some type of overmold onto it to provide for the strain relief to bite onto the connector as well as the cable. So for the most part, yeah, most connector designs can have a strain relief attached to them. Let me see. I think that's about all the time we have right now for questions. And again, I'd like to thank you all for attending the webinar. If there's any additional questions that I'll definitely answer them over the next 2 to 3 days. But again, I would like to thank you all for participating in the webinar. And if anything comes up, feel free to contact us and we'll get back to you as soon as we can. Thank you.